Okay, thank you. So let me restart, okay? So my name's Keith Short. I'm an architect in the Enterprise Tools Group inside Visual Studio. And one of the things I'm going to be talking about for the next hour is the role of the tools can play in in assisting us build applications that conform to service-oriented architectures. Now, if I give a quick summary of sort of what I intend to talk about, one of the things that I hope you've begun to understand by listening to Pat and Dave talk this morning is that building service-oriented applications is actually quite a complex undertaking. And I'm not talking about kind of very simple service applications that one can do today, where you just have a simple service that you're doing a simple request and response to from an application program. I'm talking about building the kinds of applications that you saw exemplified in the previous presentations, where you really do have to think hard about what functionality of business processes are actually petitioned to individual services, what effect that has on the messages that they then interchange, what effect that has on the sequencing of those, and so on. But getting that right for sophisticated service-oriented applications is actually quite a challenge. Now, most of what we've heard about in the conference up to date is about the great work that has been going on in the frameworks teams around Indigo, for example, and the other web service extensions, individual programming language, and of course the server teams, all working very hard to make this, some of the complexity of building service-oriented applications much easier for people to understand. And that work is ongoing. What I'm here to talk about really here is what is the role that tools can play to help reduce some of this complexity too. And specifically, I'm going to be talking about almost a taboo subject in many developer conferences these days, which is there a role for modeling languages to help resolve some of this complexity? And I think anybody who's had a bad experience with modeling technology, case tools, and various other things over the last 5, 10, even 20 years, for as long as I've been around that topic, may have built up a kind of distrust and fear of anything remotely connected with using that kind of technology. And one of the things I want to do this morning is to give you an indication of how we at Microsoft are beginning to address that issue, because I do think if we do this correctly, that some of what modeling technology was about can be directly related to reducing the complexity of building these increasingly complex kinds of applications. So just as a quick summary of where this complexity is coming from, we're actually hearing a lot more back from customers as we talk to them that, actually it is a pretty good idea that somehow if we understand what the business is doing, that somehow that's going to help us build better applications that support the business. And so business process modeling has sort of come back on the agenda. It's been on and off the agenda for development over the last 10 or so years. But it's very much the focus as people are starting to understand that building building applications that conform to service-oriented architecture is often about trying to figure out how you can support value chain processes with the applications, and you can compose those applications in interesting and complex ways to support the elements of the business process. And all this is about ultimately improving, lowering operating costs and getting applications built so that they can help the business get to market with products faster. And of course, we've had this year yet another sort of scare about the fact that, hey, maybe all this investment that businesses put into their IT groups isn't quite paying off again, okay? We're starting to hear, for example, in the recent Harvard Business Review article that challenged whether IT was actually worth the return on, giving the return on investment that business people actually expect. And I've seen this happen at least in sort of 10-year waves. I remember, I think it was about in the late 80s when Paul Strassman wrote an influential book, again, challenging the role of IT in the ROI question. And that's sort of back to haunt us again. But against that backdrop of people trying to build applications now that have these new kinds of profiles, where self-service is very important, where business-to-business is very important, but against all that, we're now hearing more about these new kinds of architectures for applications. Really, many of the things that Dave and Pat were talking about this morning were illustrating some of the concepts around structuring applications in this way that are now starting to give us this new way of thinking about apps and the new the sort of spin-offs and implications of thinking about structuring apps in this interesting new way. So, of course, while that's going on, we've still got the same kind of underlying technology that we've been using for a decade or so, plus the new technology that's there to support this kind of technology, the kind of architecture that we've been talking about this morning. So a lot of stuff to do with actual implementation code and the sort of dreary drudge of actually getting stuff implemented, the artifacts that live in a solution, is still there, and all those things are just getting more and more complex. I actually meant to look up this week how many file extensions are registered inside Visual Studio, and I forgot to do it, but it's into the multiple dozens. So that just gives you some idea of the complexity of the solution structures just inside our products that, sadly isn't getting any easier. So no wonder that the poor old developer is kind of swamped with this complexity. We've got these changing business requirements, we've got this new way of building applications, we've got all this implementation technology, and people are just struggling to understand how to build applications that are going to work in this way. Now, this is not a new problem, right? So about, let me see, say 10 or 12 years ago, I would say that it would, in that era, it used to take about your best 5% of developers to build client-server applications. Anybody remember those years of building when client-server technology was first coming out? It took the very best people to do it. And one of the issues there was that it was just a very complex new set of concepts that developers had to get their arms around, and not everybody made the hump straight away. And it was really about trying to say, well, how can I make it simpler for ordinary developers to understand those concepts and then use these underlying technologies in an easy way? And the problem is, whenever we get a technology hump, like the one we're now experiencing, what we deliver first is all this low-level implementation language and framework extensions that people now have to get to grips with, whereas the new concepts, such as were introduced in client-server, remain in people's heads, and they have to figure out how to build those in these low-level implementation languages. Now, one of the things that we did in the client-server era there was actually quite interesting, because you can come out with general-purpose programming languages that help you through this technology hump. So, yeah, of course, you could always build client-server applications in C++ or whatever it was. But again, it was that kind of top 5% of developers that could handle it. But one of the things that's interesting is to say, well, can I actually somehow dig into these new concepts and surface them in an interesting way so that I can say, yeah, but when I'm thinking about building client-server apps, I'm really thinking about what's on the screen and how that information relates to the underlying code on the server. Could I somehow abstract that information out of the general-purpose programming language and give you a way of thinking about that aspect of the problem to make it easy to solve that part of the application? And if you think back to what happened in the early client-server days, that's kind of what happened. Around the sort of early 90s, there's a bunch of things that happened, but one of the critical things that happened was that Visual Basic came out with a few very simple abstractions and some new runtime code in the framework, which allowed developers to understand what client-server was about. Came up with the notion of a form and a control and relationships between those, and made event-based event handling very easy for ordinary programmers to deal with on the server. So by introducing those few simple concepts or abstractions and the supporting runtime code, we were able to turn that 5% of developers who are able to build client-server applications completely around to the point where by the mid-90s, almost every developer could build an effective and efficient client-server application. So it is possible to do things like that. What actually happened is that you can take these sets of abstractions, and by tumbling in more concepts into underlying frameworks, it allows you to surface those through special purpose tools and languages that allow me to focus on aspects of the overall development problem at a time. And that's what happened with the form and control. So now if you think about what is happening with building these much more sophisticated service-based applications or service-oriented architecture applications, again, as of today, with the current prevailing technology and languages, it takes probably the best 5% of developers to build effective, efficient, distributed applications using those concepts. Just think of all that stuff that we heard from Dave and Pat this morning, how challenging that is for ordinary developers to do some of that, to get some of those concepts right. So we have to go back to principles and say, can we get it to the point over the next few years where it's not the top 5% of developers that can do distributed applications according to service-based principles, but can we get it to the 95% again, where ordinary developers with ordinary skills in most enterprises can actually build efficient and effective connected applications using services? And that's kind of the challenge that we're taking on in the tools group, to figure out how to do this. And we know that if we can somehow learn from what took place in that Visual Basic analogy with controls and forms, that maybe there's this idea that we can take very specific aspects of the development problem and surface those in new techniques like modeling languages, where I've got now a very narrow scope. I'm just going to worry about, say, how I worry about the connectedness between services. I don't have to worry about the underlying implementation code. If I can think just about the connectedness of those services, then perhaps I can get some traction there and figure out how I can ease that development problem. So if we can come up with the sort of analogy to forms and controls in these connected systems, then I can invent these new, very focused, narrow scope, and potentially graphical languages which can help me solve some of these complex problems involved in building these kinds of applications. So take the example. Imagine now that we are trying to build connected systems using web services. So you've seen the kinds of drawings that Pat had in his talk, for example, where I've got lots of services and lines going between them and so on. Let's just imagine that what I'm trying to do now is provide some set of techniques which allows an architect or a designer or perhaps a developer to think about the connectedness of that application or set of applications separate from the underlying implementation. So I just want to hold in my head for a moment, what is actually going on? What business activities am I going to map down to these services? What messages do those services then need to interchange? What is the sequences? What kinds of contracts do I want to build up to support that group of applications? What's my issues with security of that? Oh, and if I change my mapping of business functionality to web services, what happens to the sequencing that's involved between those? If I move a function of my business process from one service to another, then the contract between those two things will change. So that's an issue. But these are this is the sort of terminology of when I'm trying to think through this part of the problem. So just imagine that we could get to the point where this complexity that I was talking about, in terms of expressing concepts such as messages, activity mappings, security, and so on. Imagine I could put something in between that set of vocabulary and terminology and these very low-level implementation languages that we kind of got to grips with. And one of the interesting things that you could do there is that if you take, for example, today's challenge of building web service-based applications, then the concept of a connection between two services, or the contract that's offered by a service to others, is about how to take those elements and find that they've become scattered across a number of artifacts in the solution. So you can see them illustrated here. If I take the example of a contract a definition of a web service, and I look inside the Visual Studio solution to find out where that's been placed, it's scattered across a number of different artifacts. So as a developer, I'm having to worry about keeping all of those things in synchronization. I'm having to worry about how the model in my head of connectivity between services has been translated into these multiple artifacts. And really all we're saying is, what if we can invent some specific notation or very specific kind of techniques that can address the issue of thinking about the connectivity between services? Let's just say we've just invented a web service interaction domain-specific language, a language, or a visual language probably, which can help me think through those aspects of my application design which are about web service interconnectivity. Now I can use that language or that modeling tool to help me think through those aspects of the problem and allow the runtime, the design time engine inside Visual Studio to worry about how that translates into all of these other artifacts and keep them in sync for me, so I don't have to worry about it. So replacing this set of scattered information in the solution by a single holistic view could be a real asset to people trying to kind of cope with this complexity. Now, of course, to do that, I need something in the design environment to help me do that. I'm going to need to define this terminology, like the web services, the contracts, the messages. That's the terminology of worrying about how my applications are connected through web services. So just imagine I could define that as a new, I'll call it a language. I would need to have some definition of that terminology and the relationships between those. And sort of those of us in this kind of weird modeling community tend to call that a meta model. It's the definition of the interesting abstractions on a very focused area of the development problem. And you know, it's great if I can define graphical notations for those things, because often when I'm interested in getting a holistic view of stuff that's scattered across multiple artifacts in a solution, it's the interrelationships between those things that are really important to me. Seeing connected services visually, because we all draw those kinds of diagrams that Pat had in his talk on our whiteboards, but it's being able to use those visual relationships to help me think through the structure of my solution. And yes, of course, I can always go look at the code. I can read lots of lines of code in the solution to figure out what those connections were, but being able to see them graphically often helps. Oh, and by the way, I'm going to need a synchronization engine to cope with this new document type that I now have in my solution, which shows this holistic view, but has these relationships to the other artifacts that I need to keep in sync. So the interesting thing is, how can we sort of follow up on these kinds of ideas to begin to address some of the complexity that the developer faces today? So I want to show this sort of outline here of how we could imagine a set of domain-specific languages. And I'm sorry for that kind of clumsy term, if any of you are not familiar with it yet. I just spent a couple of days at OOPSLA on the other side of town. And there's a couple of tracks at OOPSLA devoted just to this topic of domain-specific modeling languages and languages. So this is becoming something the industry is talking about. And it's a useful, though clumsy term that helps get this notion across that if you can get a reduced focus set of concepts, you actually can help people resolve complexity. So what I've got here is a grid in which I'm going to place some activities that are concerned with taking business requirements and getting down to bits running on servers. So obviously I've got some business work to do in laying out my strategic objectives, understanding my requirements, fathoming out what kinds of business processes actually need and can be supported by technology and so on. And once I understand those, I can start to think about what are the key business entities and the key business processes that are suitable candidates for implementation inside information technology. I need to start to think at a pretty early stage, what is my data center going to look like? What sort of capabilities am I going to have in the technical architecture in order to support the kinds of applications I think must exist to support my strategic objectives and the business processes? But eventually I start to move down across the page. I'm starting to think less about the business, more about how to use IT. I'm starting to move from sort of planning into high-level design. And in the case of a service-oriented architecture system, then I'm now starting to think about, okay, what are those services? What are the messages that interchange between them? How are those contracts structured? What is the scheduling or the sequencing involved in those things? So that's the sort of terminology bubble that we were just looking at. But, you know, eventually we're going to get down to these implementation concepts. I'm going to have database schemas, chunks of code, XML schemas, and so on. All of that stuff will finally get built. And, you know, sort of meantime, I'm starting to flesh out my data center. because ultimately we're sort of finished with this picture, I think, when I've got bits running on rural physical servers and network segments down in the data center. But notice I put that little bubble in the middle at the bottom because that's a sort of halfway stage, a representation of the data center in a logical way that I'm going to come back and talk about in just a minute. But of course, the sad thing is, when I really understand my business processes, and Pat made this point earlier on, is that much of what my business process actually is cannot be supported by information technology. There's still a whole bunch of manual stuff that has to go on. And in fact, intriguingly, if you look at languages which have attempted to describe business processes, the bit that they nearly always miss is the human interaction part. And unfortunately, that's still very important because even with a great, for example, a great B2B system working between two companies, when stuff goes wrong, the first thing that somebody does is to pick up the phone and call. And that's a very important aspect of fleshing out these overall solutions. So laying out these sets of concepts in this grid like this allows me to say, yeah, but all of these things are very tightly interrelated. And in fact, I've described this as if one sort of starts in the top left and ends up down in the bottom right. But in actual fact, as we well know, lots of development proceeds from the sort of bottom right up to the top left. And therefore, it's very important that we can try to exploit these interrelationships between these groups of concepts. Not only because we might be able to use tools to drive down from the top to the bottom, but also when we do work from the bottom to the top, that we can reconcile the information and make sure that that is kept in synchronization. So what I want to do is just take a look at, take a look at the kinds of things that are inside these little bubbles. Because we can dig in there and find that every work product that actually gets defined inside one of these little bubbles is potentially a separate modeling language. In that case, it could be a separate DSL, or domain-specific language, or at any rate, it's a vocabulary that is specifically chosen to help somebody think through that aspect of development. And of course, it's crucial that we really understand and know how to deal with these relationships that exist between, or mappings that exist between these parts of this diagram. Now let's just drill into one of them, and obviously I've called these here viewpoints. And viewpoint is a technology word that comes out of the standardization of enterprise architectures. I won't say too much about that. If we think of a viewpoint as being one of these bubbles, let's really have a look at what's inside one of them. Now, so far I've talked about these as sort of terminology bubbles or potential new languages that help us think through some aspect of development. But it's not just about those languages, because in there I want to have patterns of those vocabularies. Okay? So when I'm thinking about web service interconnectivity for my application, I'd like to think about patterns that are about web service interconnectivity. So I don't want to think about code patterns at that moment. I want to think about patterns that are relevant to the problem on hand, which is just thinking about interconnectivity. There'll be special frameworks that I need to bundle into that bubble, and reusable components, and aspects. I'm going to come back and talk about aspects in a minute. But I'm certainly going to need to have a knowledge of how information at that level is transformed into other levels. For example, if I have my web service interaction language, then how does that translate into all those artifacts that we saw in that earlier picture? And what kind of constraints exist between these two? I'm going to go through and give examples of each of these things for specific scenarios. Now, a lot of what you heard Dave just talk about was the differences in the kinds of data that exist between services or inside services. And all that's very important too, because that represents interesting patterns for how, in this particular example, data needs to be structured between services and inside. So those are interesting too. But what I want to do now is just clear out a bit of this diagram and focus in on one specific scenario that shows how, if I had these formalized approaches to describing, in this case, web service interaction, and knowledge of my underlying deployment environment, then how can I reduce some of the complexity that we find in building service-oriented architecture programs, systems, and what the role of tools might be for that. Now, many of you would have heard reference in the other sessions at the conference to the Dynamic Systems Initiative, or DSI, which is really an initiative that's about over time, virtualizing the data center to make dynamic resource allocation of machinery and software in the data center automated through the underlying operating system. And it's very important at that point that we understand exactly what is the data center structure in terms of the physical hardware that's sitting out there in the room. I'm talking about servers that you can actually go and kick. And if you lift the carpet up in the data center, you see the wires running underneath it, the real hardware. And that's a layer inside this initiative, or the focus of this initiative, that is all about the hardware. And there's another set of concerns, which here I've shown as the next layer up, which is all about the network topology and the actual operating systems and versions that are physically deployed onto those things in the hardware. So that's an interesting set of concerns, but it's possible to take the knowledge of what's out there in the data center and abstract it down so that you just leave the information that is relevant to an application designer. Because that's the final layer here, is that if I have a knowledge of my application structure and I have information about the deployed or summary information about the software that's installed on server types, then I can use the constraints or mappings between those to help me solve deployment problems early on in the process. So all of that is made possible inside the DSI by this schema, which some of you may have heard about, called the System Definition Model, which in a sense is a schema that covers all of these 4 separate concerns. So I won't say anything more about the DSI right now. I want to move on and just focus on, in fact, I'll just focus on the top 2 layers, which is the layer of expressing my application as a set of connected services and how I can utilize information about the deployment structures as early as possible to save deployment problems downstream. So some of you may have got to the session that was actually took place on yesterday afternoon, where we described some of these modeling tools that we're producing for Visual Studio Whidbey. We discussed an application designer and a logical data system designer, which are tools which are based upon these very specific languages for solving 2 very specific problems in the overall challenge of building these kinds of applications. So, and then mappings between them. Now, if you look at, say, a domain-specific language in action today, this is the kind of picture that we're all drawing today. This is roughly equivalent to some of the pictures that were in Pat's talk a little earlier. So here's a bunch of services. Here's the kind of interconnection between them. And, of course, this is all being played out on a whiteboard. Well, the other problem is that if I'm now a developer, how many of you who are developers have got a picture a bit like this of the data center stuck up on the wall somewhere? Okay, 1 or 2 of you maybe. How useful is that picture for you when you're designing an application? Okay? Well, the answer is it's not terribly useful quite often, because this is a picture of the kinds of stuff that's out in my data center and the sort of interrelationships that are permitted between server types and firewalls. But quite often when I'm actually designing my application, I'm talking about connectivity between services. I hadn't even a clue that there might be a firewall sitting between 2 connected parts of my application. And quite often when I set up authentication or security or other deployment information for my application, I don't discover that it won't deploy on something like this until much, much later in the day. In fact, typically it's when we try to deploy the app. And fixing problems with the app deployment time is just very, very expensive and time-consuming. So here's an example of what I've been talking about. This is a modeling tool. Okay, is it a modeling tool, or is it just some abstraction of stuff that lives in my solution that I could go read about in code or web config files or WSDL files or whatever it is, and somehow revisualize that back in a way that more correctly corresponds to the way I think about the problem of designing connected applications. So using a tool like this, I can now understand those aspects of my problem that are about connectivity using a very specific tool to do so, but be guaranteed that the impact of this structure on individual elements of the solution, like WSDL files, like web config files, like class files that inherit from web service, etc., and the project structure, to have that automatically managed for me. And now if I have a picture like this, I can think through the structure of my application and focus on that part of the problem. Also, as we'll see in a moment, that if I have a picture like this is now the spot where I can do special purpose patterns. Because if I've got patterns that are about web service interaction, I'd rather do them on a picture like this than do them when I've got down to code and I'm now dealing with code patterns. It's just easier to do them at this point. Now, of course, rather than that picture that I showed you of a data center architecture, maybe a picture like this is actually a little bit more useful. Because this is the other tool that we showed at the conference this week with the ship with Whidbey, which is here the boxes represent types of server in my data center. The connection lines represent the sort of permitted protocols that are allowed to flow between those box types. Properties of these box types represent what software is installed on those server types. So, of course, these are scale invariant. Each one of these boxes may represent the settings and software deployed on 100 real servers in the data center. But if I have a picture like this, now I can use that metadata about the deployment environment to validate that I've actually got the correct application emerging. So imagine if I could put these two things together and then, in fact, draw mapping lines between them. I can exploit the fact that I have two sets of metadata at different levels of abstraction to cross-check that deployment problems aren't going to occur downstream. And this is a very important scenario that we wanted to nail in Whidbey. Even though the technology platform is still evolving, deployment of web service-based applications is still a big problem for everybody. So here's an example where I've got two very specific modeling languages that have got an interrelationship between them. In this case, it's about matching deployment policies and security policies and so on. That if I can offer those as tools that very tightly work together and which themselves synchronize in real time with the underlying artifacts, I can actually reduce some of the complexity inherent in the problem. So, for example, I mentioned patterns. In the web service interaction, there's a whole bunch of them. And in fact, the latest edition of the guide issued by the Patterns and Practices group at Microsoft has just appeared as a Microsoft Press book that it now includes a chapter on web service interaction patterns, things like the service interface and gateway. And facade is another one. So this allows me to say I can now define patterns in the language of web service interaction. That's a good thing. And now I can use that diagram that we just saw as a means to host the application of certain patterns into it. Likewise for the logical system architecture patterns. The second diagram I showed you. The Microsoft System Architecture Group produces patterns of server types, firewall types, connectivity types, protocol things, and settings for IIS and so on. They actually produce those as sort of useful starting points for certain kinds of data center architecture. And in effect, those are patterns expressed in the vocabulary of the second diagram. How many of you here know about aspect-oriented programming? A whole bunch. Good, because this is a developers conference. Quite often when I talk to business folks, it's just a very small number of hands come up. And of course, having just been at Oopsler for a couple of days, aspects are all over the place too. Here I want to talk about aspects in the role of these modeling languages, because I think most of us here are familiar with what aspects mean in programming languages, but by analogy, I can think about aspects in these modeling languages too. So, for example, if I define a security policy and I wanted to wash it across multiple of those connections, the web service connections in that nice web service interaction diagram, then that's a lot easier if I can define that once and have it cross-cut across multiple positions in my solution. If I can do that on that diagram, think of all the code that I'm saving myself actually writing. So we'll take a look about that too. But also in this little bubble, we've got transformations. We saw how we can use the constraints between a language that expresses my application and a language which describes my data center, and I can use that to good effect. We also saw the kinds of transforms that are necessary to take the web service into connection and turn it into real live artifacts inside the solution. Let's take a quick example of that. Imagine we've got this sort of very simple connectivity thing here. So I've got a bunch of services, and they're apparently connecting in these interesting ways. But a common thing is to say, okay, so I've got this ready-defined service, and it operates behind the firewall, but I want to build another layer of that which exposes some of the functionality of that particular service, but now deployed into a new spot in my data center with different security policies. And perhaps it offers a subset of the actual messages that the base one did. So I can construct something called a service facade, which might say, okay, so tell me about the, what this thing should do, which of the messages should it expose across this, in this new way, and I can embody that in a pattern so that I can now say, okay, it's now those set of messages, and I can then allow the pattern expansion to build a whole bunch of useful stuff for me in my solution, things that you can see here, and get that turned into that new project in the solution and save me as a developer just a whole bunch of work doing. So this is a very simple example of where I can express a pattern in the language of web service interaction and allow the underlying engineware to do the right thing to simplify my job as a designer. So here's another pattern. This is actually a pattern of service interaction that comes from the Patterns and Practices Guide. So I won't drill into this now. You can go off and read about that on MSDN, the various articles there. But this is just another example. So imagine that we could somehow schematize this information and load it into Visual Studio and just have the project structure that matches the needs of this pattern created automatically for me in terms of that language of the web service interaction I just described. That would be pretty cool. Aspect weaving. Most of you put your hands up, so I don't have to explain what an aspect is. But those are few that didn't. An aspect, very, very briefly, is a part of your program which really isn't doing very much to help the main functionality of the program, but is much more concerned with things like security or error handling, instrumentation, anything that is really about non-functional requirements implementation. And what you'd really like to do is to take that stuff that's scattered throughout your source code and put it into a point where you can define your security policy once, or how you handle information, instrumentation once. And now in the programming language world, the world of AOP, then you get compiler-based or runtime-based mechanisms that weave that information back into the right points in your program. The point being, it's much easier to maintain and onward develop your code if you can refactor out those aspects, the non-functional implementation aspects, store them once and have something else blend them back in. And that's the guts of what aspect-oriented programming is about, but it also works at these other higher-level languages like web service. So, for example, I can say, imagine that I've got a framework that supports instrumentation. Well, there's a few facts about that that I need to know. I need to know what the framework is and how to call it. But here I'm using some borrowed terminology from Aspect J just to illustrate the point. But there are certain insert points into my services where this makes sense to put. So I can say, okay, so I'd like to put that stuff into these services here, and I can then allow my transformation routines to build all the relevant bits of code to call those and have that woven into my model. So it's very much like aspect-oriented modeling rather than aspect-oriented programming. And there are a number of those things that are interesting. So let's go back to my little chart here. What we looked at there was the relationship between two of these bubbles and how aspects, patterns, and transforms can really help me solve certain complexity problems that are about these adjacent bubbles and exploiting the relationships between them. Let's look at another one. And this one's a much harder one, sadly. What's the relationship between my definition of my business processes and a strategy for implementing them using web service and service-oriented architectures? Well, sadly, that's a pretty tough question. So I'm not going to stand up here today and tell you that we've solved that problem. But let's try and rerun the conversations we just had about the other relationship between those languages and see if we can learn something about how we might solve this problem. And in fact, I'll wind up this section in a moment with a slide that says why it's almost impossible to solve this in a general way. Well, there's a business process map, okay? These things can get pretty complicated in a hurry. Now, sadly, there doesn't exist today a single language that any organization or standards body has successfully defined that helps me build a definition of something I can show in a picture like this. This is quite a complicated one. And even those that have tried to do this tend to focus on the strategy that is IT implementable and ignores some of the error handling and the human aspects of implementing the business process. So we've got a problem here that we actually appear to have quite a sophisticated domain with a lot of concepts in it and not a lot of practice and experience that we know about for how to turn these diagrams magically or automatically into strategies for solutions. But what's the terminology we've got? Surely we can have a crack at this. We've been worrying about getting business process modeling languages for at least 20 years that I've been involved in them. So why haven't we made a whole lot of progress here? Well, here's a few of the terminology. We've got business activity, so each of those little boxes on that last picture are probably an activity. I've got business event. I've got dependencies between them. You have to do this before you do that, and don't do that unless you've done this, and so on. Business entities are things that people often talk about in this context. So this is the sort of data thingies that are moving between activity thingies, and sometimes I want to dress those up as documents, and so on and so forth. So what we can define is some of the terminology of this domain. So it ought to be possible for us to come up with a domain-specific language or a language which allows us to describe the task of understanding business processes. Well, there's been lots of attempts at that. Some of them have been more successful than others. But let's assume that we can get to the point where we could actually do that. Because then, if we can express our understanding of business processes in a very formal and rigorous way, now I can do all those fun things with patterns again. So I can think about what are process patterns. Could I look at that picture of the order processing activity map and maybe kind of step back from it and start to see patterns emerging, patterns of interaction or dependency between activities in the process map that are a clue for me to how to implement them in information technology. For example, I don't know how many of you in the room here know our BizTalk product. Well, BizTalk server ships with an orchestration engine, and you can describe how an orchestration engine can schedule other services to get work done, okay, in a very message-driven and asynchronous way. So that's a great technology solution for some parts of my business process. If I can spot the pattern in the process that says, hey, do this, then do that, then either do this or do that, then wait for this to happen. You get the picture. That I've now got a pattern emerging that says, hey, when I spot those sequences of activities in a business process, then maybe I could use an XLang schedule to implement those things. Well, that's good. But XLang schedules are not good if I've got a bit of my process that says something like this. Hey, do this. Or if this happens, do that. But if this happens, do this. Or if that happens, do that. That's a very poor part of my process as a candidate for implementing in a schedule. So maybe I want to look to some other technology to implement that part. We can see what I'm getting at here, because not only are patterns useful for helping me structure a solution, they're also very useful for helping me convert from one set of structures to another. So, for example, if I can find these patterns in business process diagrams, then maybe I'm starting to think about how I can, if not automate, at least assist with technology, how I can get implementation strategies for those. But to do that, I need a good definition of my business processes. I need a good way of writing these kinds of pattern-based transformations and having an engine at runtime that allows me to manage all those and get that right. So I mentioned sort of in passing that it looks like a kind of sad reflection on our industry that over all these years we've not been able to emerge with a great business process language or business process modeling language that solves everybody's needs. And part of the problem is illustrated by this picture. Down in the bottom right-hand corner of this picture, that's about platforms, right? It's a focus on platforms. Well, guess what? There aren't very many platforms for doing distributed applications using services, okay? Well, we have one at Microsoft. Of course, there's others in other companies. But it's few, not lots, okay? So the variation across the types of platforms is not great. But almost every single business has a different way of doing modeling its processes. And it's very, very difficult to come up with a standard process modeling language that can model everybody's approaches to doing business modeling and be the basis for moving into platform-specific or platform-independent technologies and implementation technology. So it's the differences in those variation that causes us a lot of problems. So one of the things that we can learn from this is perhaps what we should be doing is coming out with a sort of simple or skeletal process modeling language with a designer to support it, but expect everybody to quickly customize that language to their own needs and quickly customize the designer so that I have a designer for my customized way of doing business process modeling. So if we look back to the requirements now on the development environment, we're going to need to understand how to do rapid extensibility of modeling languages. Boy, is that a tough problem. So we know that we need to have a way of describing these very specific aspects of the development process using new languages. We know that we need to be able to take either an existing model and modify it, a language and modify it, like a business process language. We want to be able to do these graphical notations because they're very good at giving us the holistic view of these complex interrelationships. We want to be able to build patterns, and we want to be able to define aspects. So somehow the underlying machinery must allow me to do all of that if we're going to be successful in reducing the complexity. But guess what? It doesn't stop there. If I'm picking up all of this great metadata and doing useful things with it in the process of development, surely I can make even more use of it in the rest of the tools that I have to deal with in development. So just imagine that we had a source control system that understood what a web service was. Okay? Now just think about that for a minute. What I'm saying is that today most source control systems understand source files, right? They understand text files that have some meaning to the developer. So you can't go to, say, a source control system and say, get me all the stuff for this web service, please, because it doesn't know what a web service is. Okay? So now imagine that you could spike your source control system with information about these abstractions, so that when you went to the source control system of the future, you say, give me all that stuff for this web service, or these web services and the contracts between them. I would just get all that automatically loaded into my workspace. Same thing for debuggers. Just think about how debugging might be improved if I could capitalize on some of this interesting metadata that's now available. That I could talk in terms of debugging about the interaction, about a contract, for example, and debug a contract rather than debug the code that underlies the implementation of the contract. Testing tools, same kind of thing. And even we're beginning to think about, at Microsoft, how compilers and individual language editors could become much smarter and more useful if we can exploit this additional metadata that we can capture around these other abstractions. So just to wrap up, I want to say that one of the things that we've been doing in the tools group is to take on this challenge of how we can invent new language extensions, new frameworks to support them, and new modeling languages that give this interesting property to resolving complexity, and tumble all that into our tools environments so that we can help you build these new kinds of applications. So we've been focusing very hard on building an initial set of these model-driven development tools along the lines of what I've been saying, and looking at how we can then feed that information out as metadata to other kinds of tools in the environment. And last but not least, the tools that we have built, that I showed you quick glimpses of here, and you could have seen at other sessions in the conference, are themselves built on a modeling engine and framework that does all of the things that I've just been saying. So it allows you to define meta models or extend existing ones, very quickly. It allows you to describe transform rules between those models. It has a synchronization engine that allows a model at one level of abstraction to be synchronized with a whole bunch of artifacts, much as I said. So that is a piece of work that over time we hope to be able to offer both to our partners and customers so that you can build those kinds of tools yourself. So obviously, the ones that we've focused in initially are really to try to nail a couple of crucial scenarios around web service development and deployment. That is, how to give a richer design experience for connected systems using web services, and then how we can use metadata from that design and our knowledge of the deployment environment and use that as a design time validation step that then avoids a lot of downstream deployment problems. And basically, those are the aspects of this problem that we're trying to hit first. Now, we recognize that extensibility is very important, so we expect people to take those designers and the underlying structures and be able to add your own stuff to them. But given that kind of engineware, we think that this approach of very specific, well-focused, narrow-scoped modeling languages, backed by great visual designers, can now be a very useful and indeed first-class artifact in a solution, and sort of banish forever, we hope, the fact that people view these models only as documentation, something that gets out of date and is not worth the trouble. But if those can be live and first-class sort of artifacts inside the solution, we think that we can begin to switch people's view of the utility of doing those kinds of adding that step into the development process. So some of the stuff that I've been talking about is available on a couple of white papers that we've put up onto this website. The other one that I haven't referenced here is the patterns and practices site, where there's a number of papers concerning guidance and so on. And I'd invite you to go to those websites and read more about this kind of the guidance we're giving and our approach to modeling and the tools that we're building first. So I thank you for your attention. Thank you for coming to the seminar. Thank you. Thank you. Just before I take some questions, I do want to remind everybody that the panel session for the symposium begins, what time is it, Mike? 12:45? 1:45. We do have some great panelists for you to direct questions about the morning's ideas. We have Mark Griver from Gartner Group, Linda Northrup from the SEI, Software Engineering Institute, and Martin Fowler, who's a well-known author and consultant with ThoughtWorks, and they'll be up on stage to take your questions. But now I'm ready to take questions directed at me. Yes, sir.
The DSL language that you specify, is it a set of stereotype of UML or a totally separate new language?
I'm sorry, could you say the question again?
The DSL
yes.
that you indicate in your slide, is it a set of a stereotype of UML or totally new thing?
Okay, so the question there for those who didn't get it was, is this notion of DSLs going to be implemented as a set of stereotype extensions to UML, or is it something different? Now, the answer is it's something different. And one of the reasons is that if you know the UML well, the underlying meta model for UML is still too ambiguous to be used as the basis for hard transforms between two languages.
Okay.
And so we've been working on another approach that is much more focused on supporting these well-focused, narrow-scope domain languages that can be very precisely interrelated. So for that reason, we chose not to do it using these somewhat poor extensions to UML, such as stereotypes.
But what you recommend us, let's say, because we still have, let's say, object modeling we need to do when develop the application, no matter it's servers or whatever. So we should use both in, let's say, UML and your DSL, or DSL will support the object model too?
So over time, we will offer equivalent solutions such as class modeling. In fact, we're going to have a class modeling tool which is a DSL based upon our infrastructure, which will ship with Whidbey. We were showing that at the booth earlier in the conference. And so, but that is not a UML tool in the sense that it uses the UML type system. It is actually a visualization of languages expressed in the CLR. So there'll still be room for people who want to use the standard UML diagrams alongside these more specific focused tools that we've been building, because UML actually doesn't have defined as a part of its definition today tools that really address things like the logical infrastructure modeling, or in fact the web service interaction. So today those would have to be rather crude extensions to those languages, and we thought it better to just do a really good job of defining those meta models as first-class models.
Okay, thank you very much.
Yes, sir.
I guess a follow-up, or sorry.
No, that's fine.
Okay. Just a follow-up on that one. So if you're basically not using UML in terms of your approach to all of this, and you're going it alone and kind of doing a whole other thing, because it's going to be more specific to this particular platform, does that inherently imply that this will not be a generic modeling language that I could use with other platforms?
Well, there'll be nothing to stop anyone taking an implementation of what we've done and writing transforms to other platforms, because that's part of what I was describing, that it's possible to take that meta information captured in that particular way and use it to whatever purpose you see fit. Now, we're probably not going to be writing those transforms that go to other platforms. We're only interested in the transforms that go to our own platform initially. But as that tool set becomes more widely available, we expect partners to do something like you just said. Does that answer your question?
Well, yeah, I think it does. Basically, this will be open to other people if they want to take this and extend it.
Yeah. So, for example, we anticipate, though I can't confirm today, that partners will probably take our infrastructure and build standard UML tools on top of it for those people who still want to use the tools that come with UML for whatever purposes that they're directed at. But what we chose to do was to take aspects of the development, particularly in the web service design and deployment scenarios, which are not well covered in those other modeling languages today, and just do a really good job of having precise languages that can be the basis for tooling with an unambiguously specified model underneath them. Does that help?
Yeah. It does.
I think, just as a sort of punch point there, I think it would be unwise of us to use different notation than UML for concepts which are identical, and that's absolutely in our plan. So if you look at our class design tool, for example, which is a visualization of CLR languages, then we haven't come up with a cloud that represents a class or something wacky like that. You're going to have anybody who's used to the UML notation will look at that and know what it represents. But I think one of the issues, if you've seen UML diagrams that have been heavily extended with stereotypes, that starts to look less like a great communication medium, and you feel the need to go define a notation that is more adequate to that specific domain. Okay? Thank you. Yes?
Hi.
Hello.
Can you please explain whether your approach is compliant with MOF standards, metadata and meta models?
It is not right now.
Right. Any
Okay.
plans to make it compliant?
I think the plans are going to be more like how one can interoperate between those two. And that's just a piece of work that we haven't started on at this point. Mostly, I think, because it's a little too early to standardize those approaches. We're sort of great believers in really getting the underlying technology to work first and then figuring out how the standards process should work. But I have to say, one of the things that we have tried to do is to build, you're obviously familiar with MOF, so you're familiar with the term meta languages. So what we've tried to do is to capture one that is obviously got very similar concepts in it to MOF, but is very directed to this new approach, which is about a family of relatable specific languages, rather than one that was designed to be the center of a single unified giant language. Okay? So it contains concepts that are a little bit more about supporting specific relatable languages and patterns and aspects and so on drawn within them, than just being a language that could describe this giant, large, kind of interrelated set of concepts. So I guess sort of summary is that that approach is what I would describe as sort of one size fits all. But I think what you're hearing from us is much more of a choose something that's very specific, and we can provide you with engineware that can help you define that to your need and quickly build a designer that will help you fill that space up. So there was a slight difference in the sort of requirements that we took on, that Moth was good at one thing, and we wanted something that was good at something slightly different. But hey, at the end of the day, if you were to see the two models, you would quickly spot the similarities between them.
Well, they will have to interoperate when they're, out and about. That's sort of obvious. And if you don't do it yourself, there will be people who would provide tools for doing that.
Yeah.
But my follow-up question, if I may, is, do you see your approach and, Moth approach merging in the long run? Because concepts are very, very similar.
Yeah, and at the moment it's just too early to say exactly how that might happen. I think the critical answer is to say that because all of the information in both worlds is heavily schematized, then the job of transforming between the two is effectively a schema transformation one. So as long as the data is available, one can do that. And quite honestly, even today, because of the underlying semantics of UML implementations being ambiguous and up to the tool developer, that even today with common formats in that Moth universe, you end up with quite a lot of difficulty in transforming between one tool vendor's model and another tool vendor's model.
Yeah.
So it's not like we've put a new problem in your face. You've still got that problem today, even with the different implementations of Moth-based languages. Does that help?
To a degree. Thank you.
Okay, thanks. Yes, sir.
How can I support multiple...
I'm sorry, could you get nearer the mic?
How can I support multiple deployment models?
Multiple deployment.
Yeah, in the diagram that you've shown, you said that you could actually verify with the logical layer how your DSL is actually working out. Like for my company itself, we had a case where MSN was using our software in a different way, and we had a firewall where we would never expect it. So does the modeling provide for us to tell, I may have 2 or 3 deployment models, and can I provide verification for those?
Yeah. Okay, so the question was about multiple deployment models, because I might have different configurations of data center policies.
Different customers would deploy differently.
Absolutely.
So
Yeah, and yes, it can.
Okay.
If perhaps we could take this offline if you're very interested in it, but the full-blown tool allows you to host multiple logical structure designers, and then you can separately map your application design, in fact, subsets of application design, into different deployment architectures and still get that validation step occurring. So the quick answer is yes, it will. Okay? Thank you. Yes, sir?
Do you have any plans to come with a unified process like RUP or functional that cover all other issues other than the modeling? So,
okay, it's an interesting question. So the question was, do we have any plans to build something like a Microsoft version of Rational's RUP, right? Was that sort of a good way of putting it? So in fact, there is some work going on at Microsoft to enhance the MSF, which is Microsoft Software Framework, which is a sort of set of guidelines for how to structure projects and so on. Not really quite ready to discuss that in detail publicly, because it's work that we're still thinking about doing. But yeah, there's definitely work going on back in the company to enhance that so that it matches this kind of picture that I was showing here this morning with the interrelationship of steps. So we want to get guidance that says, yeah, for this kind of application, then these sorts of deliverables are the ones you should be thinking about building, and you sort of build them in this order, and these are the tools that you should be using to do that. So there's definitely work going on in both guidance and in sort of methodology, as it were, to try to match it to the kinds of problems that we see people facing in building connected apps out of web services. But I can't really answer much more than that today, because the sort of rollout plans for that work are a little poorly formed at the moment, and we'll be making announcements as the next few months roll out. Does that help?
yeah.
Yeah, sorry to be a bit vague there.
Maybe another question, a bit out of the context. Do you have any approach towards XP in regard of extreme programming?
Yeah, in fact, that would be a brilliant question for you to bring up to our panelists. But I'll give you just a quick response here. Is that we've talked a lot to people doing agile development, and there's sort of a starting point from that community that says none of this kind of high-level stuff is ever worth doing. And in fact, that's not true. But you do need to be able to have very quick interaction. I mean, having a graphical visualization of a set of classes or a set of services, if you're building, you're doing a 2-week project, I think that is just the value. And I think it's sort of, you don't want to do it if you think of yourself as writing a lengthy specification before coding. That's not a good idea if you're doing that style of development. But if it's helping you structure what it is that you're coding and allow you to think about some of the impact of the relationships between things, then I think there's a place for those kinds of modeling languages, even on agile development projects. So I think the proof point is, can we persuade those kinds of people that these sorts of tools add value to their projects? And I think the answer is yes, and we've just got that work to do. But certainly in talking to a number of people who are involved in that community, are now starting to say that, hey, yeah, I think the answer is yes. I'll take the gentleman at the back, yeah.
Yes, you talked a little bit about having a base modeling language that could then be extended for business processes.
Yes.
Could you talk to which modeling languages you're investigating right now, and if BPML is one of those?
I really can't talk about it much at the moment because we've not really started to think about it in a sort of hard way. What we've been doing is talking to some of the big system integrators and looking at the way they like to do process modeling. We've done quite a lot of work, as you've probably seen, in the UN CFAC process modeling technology. So we're starting to gather information about what that might look like. But I think the key message that I want to leave you with is that it really ought to be easy for people to define those models and build designers on them. And that's really the focus that we take as an infrastructure group. And you know what? It may not be Microsoft that ever pushes out a standard business processing language. Perhaps there'll be a few that are on offer by partner communities that are tunable to specific situations. And so perhaps we never do such a designer. Or perhaps we'll produce a core one that can be the basis of extension. So we've been looking at a lot of the available ones. We've also looked at some of the implementation technology, like BIPL. Because BIPL isn't a business process modeling language, it's a business process implementation language that's suitable for some kinds of structures. So we're looking at how the relationship between modeling languages and the implementation languages is playing out. But right now, I can't say anything more than that. We haven't focused in on any one of them yet. Does that help?
Yeah.
Thanks. Yes, sir.
I have 2 questions. One is if you're familiar with the Eclipse modeling framework.
Sorry, can you just get near the mic?
Are you familiar with the Eclipse modeling framework, EMF?
Yes.
So then my first question is, the EMF also has similar semantics where it's loosely based on MOF, and it lets you quickly build your own modeling language and the UI for it so that you go on into the cycle of editing that you talked about. So my first question is, can you compare it with the EMF? Draw the lines of comparisons. My second question is the tooling for editing the deployment configurations going to available outside Dev Studio? Because if I'm the vendor who ships a bunch of software and my customer buys it and he wants to reconfigure for his own deployment, he probably doesn't want to buy Developer Studio Architect Edition if he doesn't already own it. So that's my second.
Okay. So just to summarize that question was, how does the stuff I was describing compare with EMF, which is the Eclipse modeling framework inside Eclipse as an add-in? Is Steve Cook in the room? That's a shame, he's gone. So I'll give you a quick answer, but it's probably not appropriate for me to do this on stage. It's going to take a while to do point-by-point comparison. The quick answer is that we think that the infrastructure we've built is actually a superset of EMF. Because EMF, for example, doesn't have a good story around transform rules and synchronization engine, and that's been a key scenario that we wanted to hit. Yeah, in terms of meta model definition and some of the other aspects, it's obviously there's only so many ways you can do that. But right now we think that it's, in as much as I'm describing something that's unavailable and unannounced, information is that we've certainly comprehended what's going on there and think that we're aiming for a slightly different market with a slightly different set of needs, and that's been driving the contents of our framework. I'm sorry if that's a little vague, but it'd be probably too detailed to deal with on stage. I'd be happy to take it offline if you want to drill into comparison. Thanks for your question.
And the second question about tooling available outside Dev Studio, just as a part of maybe operating system, part of the systems management server, or
I'm sorry, I don't understand the question. Could you just...
My second question was about the tooling that lets the IT guy configure the deployment policies and the layout and all the different zones and stuff.
Yeah.
For the software package that he buys from the independent vendor, and he is not actually writing it himself. So is that tooling going to be part of the Dev Studio always, or it's going to be available separately?
I see. So the question was the tool that allows you to describe the logical data center and the connections and server types within it. Is that going to be only available in Visual Studio, or is it going to be available outside? Oh, well, right now for Whidbey, we only plan to offer it as part of the enterprise SKU in Visual Studio, because mostly that's a diagram that in that time frame, its primary purpose will be for design time validation of that metadata. But we're certainly thinking about other ways that we might expose that behavior through some of the management tools and the runtime tools as well.
Right. So meanwhile, if I sell my application, I should better be packaging the Dev Studio project file as part of my installation, so that whoever is buying it can load it up into his own Dev Studio, right?
Yeah, I think maybe we should take this again offline. It's a detail, but yeah, I mean, basically the artifact that describes the SDM file that describes all this information is just a file in the solution, so it's versioned and managed accordingly. And frankly, you could do anything you like with it. If you've got another deployment story, you could simply read the structure of that file and go do whatever you need on it. So the quick answer is it is just a metadata file that's available in the solution. Perhaps we can pick that up later. Any other? Yes, sir. Yeah.
I guess traditionally, Microsoft kind of came from ground up, the tool side, and now we're seeing a lot coming from top-down architectural side. Do you think, is it far off realistically where you can basically model all this stuff and literally click, I want a distributed application, on a web application, this is my physical, this is my logical. You kind of turn the handle and you almost generate 95% of it, and all you do is, as developers, fill in the last bit, the business-specific coding, basically. So all the kind of grunge stuff, if you want, is filled in for you, because you can infer so much, and because there's patterns for so many of these things, that you can just literally crank the handle and turn 98% of this stuff out.
Yeah. And
how far off is that?
Oh, I think it's a long way off. But I think it's a great vision. I think more appropriately is that we have to recognize that that might be a direction we're heading, but I think it's equally important to recognize that reconciliation from bottom up is an important aspect of what these kinds of tools can do for you. And just to be able to support human activities in design, like, for example, writing that program that can take a number of process implementation patterns and run across a business process map and produce an implementation. I doubt we're going to see that before I retire, for sure. I think it's just too far-fetched. But could I build in tools that could help me apply those patterns in a structured way? Yeah, absolutely. And then remember that I did so. And then handle the reconciliation between the artifacts produced in both. Yeah, absolutely. We should be able to get to that point. So I think we've got to be realistic about the capability for automation of that. And I might try to quickly summarize by saying that by the time we've done that for this technology platform, the technology platform would have shifted to something that we can't know about today, and we'll be back to square one in figuring out what the new languages are for that thing. So it's a great vision, and it's what keeps us going. But I'm not sure I can state when we're going to get there. There's some really hard problems.
My idea is that a lot of projects that you approach, it's all the same stuff basically, or essentially all the same building blocks. There's only so many combinations, relatively speaking.
That's true.
I guess.
Yeah.
And if you've got patterns and practices which describe most of that stuff, you can basically describe it, and you can describe a model, the data model. You can model most of this stuff, and it's almost like a jigsaw puzzle. You just kind of tick which bits you want and then put it together.
I think one of the things that makes that hard, beyond the kind of after dinner conversation, is the fact that those variabilities that I described, that platform variability actually isn't the real hard problem. So if you're going to take an approach to simplifying complexity, worrying about platform specific and platform independent models is only a small part of the complexity problem. The real hard thing that we should be driving abstraction towards helping us solve is the complexity of the problem space and mapping down to low-level implementation artifacts. And you know, even if you only have one platform, and even if that platform is not evolving, of course neither of those two things is true, but if you did, you still have all the complexity of structuring requirements and getting down to a solution. Just think of all the stuff Dave and Pat were talking about. So, you know, the platform issue is just like a minor problem at the end to me. And you know, worrying about the structure of the application and getting that right is a complexity problem that we can try to drive abstraction to help support. And yeah, at some point you have to map to platform specific technology. But to have an approach that's solely based upon using abstraction to whack that problem seems, you know, somewhat misguided to me. Okay, thanks for the question. Yeah.
One comment. After all, the old IEF wasn't that bad, right?
Thank you very much.
I've got a point that's a little bit similar to the guy you were just talking to made. You're saying it's too complex a problem to solve in general to get generic ways to automatically map from business processes to implementation.
Yeah.
But I mean, you have PAG that produces lots of good advice. And that is a finite set of things. Now, presumably, if the architect can say, right, we've now got this situation where we need to apply this bit of PAG, you could automate producing a framework solution based on that particular bit of PAG guidance or whatever. So you could have a wizard which says, I can't think of one offhand, but you know, it did, like the diagram you showed earlier with that particular system model.
Yeah, that's right.
You could do that kind of thing, surely.
Yeah, indeed you could. Is Wojtek still here? No, he left the room. Wojtek Kosazinski is in the Patterns and Practices group. He was sitting here earlier. But that's exactly what they want to try to do. They want to try to encode their guidance into, you know, schematize it so that you can place it into the tool, and therefore it becomes a way of setting constraints on how developers actually operate. So that is stuff that we're looking at. But I don't want to stand up here today and say, oh yeah, we got that one nailed for Whidbey. We're certainly looking at how we can do that.
Okay, thanks.
Okay, thanks. Sure. Are there any other questions, or can we